So we're still talking about limits, so we know what a limit is. As x approaches some number, what is y approaching? That's what it is. As x is approaching, either on a graph, on an equation, on a table, as x is approaching something from both sides, a number, a value, where is y at? Do they meet, or are they on different levels? Right? Does not exist, does exist, and what is that y value? Okay? So we're talking about that, but we're talking more about, we're bringing in this concept of infinity. Okay? So we talked about a little bit about this, vertical asymptotes. Vertical asymptotes are lines. They're vertical lines. Okay, they're vertical lines where the limit, the left-sided limit, is either going to in positive infinity or negative infinity. Same thing with the right-sided limit, right? So let me draw a picture. Let me draw you a quick picture to see what that looks like. Let's see here. Okay, so if I have a graph, okay, if I have a graph, let's say there's a asymptote, a vertical line, right? At 1, 2, 3, positive 3. So I'm going to draw. Usually you see these when they're graphed. You see them dotted like this or dashed like this. So if I have a graph, let's say I'm going to draw a graph. Let's say I have a graph that starts over here, and it goes and it goes, and it's coming close to the blue line, right? It can't cross the blue line. It's not able to cross the blue line. That's why an asymptote exists. There is no answer to 3, x equals 3. X equals 3 is kind of off limits. So the red line, as I'm getting closer and closer here, has 2 options. It can go hug the line and go straight up. It can get very, very close to it, right? Because it's got to keep moving this way. It has to keep moving this way. It can't just stop. Or it can go straight down like that. Oops. There you go. It has 2 options. So that's what we mean by what is the limit. We're not going to have an answer at x equals 3. We're not going to because of an asymptote. But we can have a limit. It's either going to be positive infinity or negative infinity. Right? It's going to be one of those 2 guys. Okay? Same thing from the other side. It picks up after the blue line, the dashed blue line. Okay? So it could pick up from here, or it can pick up from here. Right? It just doesn't exist at 3. So if we were finding the limit, first of all, there is no limit. The limit for this guy here, the limit as x approaches 3, we'll call this guy f of x. For f of x, dne does not exist because they don't approach the same limit, the same value. They don't approach the same value. Even though they're both going in the same direction, when they get close, they're both going in this direction, right? They don't approach the same value. Even though it's both negative infinity, infinity and positive infinity and negative infinity aren't numbers. They're just ideas, right? We know that as if I keep getting bigger and bigger and bigger and bigger, I'm getting closer to something called infinity, right? If I'm getting smaller and smaller and smaller and smaller, I'm getting something close to infinity, right? It's an idea. It's not actually a value. Infinity is not a number. It's just an idea, okay? Like my son will say, you know what the biggest number is? And I'm like, okay, what is it? He's like, infinity plus 1, right? He'll say that. And it's like, I don't tell him that because he's 8, but I'm like, infinity is not a number. So it's an idea. It's like kind of like, if we keep going out there, we'll get there. There's got to be something out there, right? Has anyone ever been out there? What's that? Exactly. It's so far out there that no one has been out there. We just have this idea that, hey, there's got to be something out there. And we call it infinity. Okay? So that's why like I'll have students say, oh, the limit as x approaches 3, they're both going negative, they're both going, so eventually they'll meet, right? We think, but we don't know that for sure, right? So that's why it does not exist. Okay? But we can have a one-sided limit. I would say that the one-sided limit okay, so from the left side, where is this y value going? Negative infinity. Negative infinity. That's where it's approaching, right? We can say, so why can I say it up here and not here? Because it's what's approaching. What is it approaching, right? It's not there. And theoretically, it'll never get there. But it's approaching negative infinity. Same thing here. From the positive side. If I come over here, approaching the same guy. Okay, so that's what we're looking at today. We're looking at things that look like this. If I were to graph them, they would look like this. Trouble is today we're not going to graph anything. We're not graphing anything today. This is the visual you will see in your head. Okay? Okay, so let's go back to this. So that's a vertical asymptote. Line which you can't cross. You can hug it to positive infinity. You can write it to negative infinity, but you can't cross it. Okay? So when does this occur? When do we have a vertical asymptote? When we have 0, in the denominator. 0 in the denominator. I should probably highlight this instead. 0 in the denominator. 0 in the denominator means vertical asymptote at that value. Okay. We talk about a hole. It's not a lot of hole questions. So I don't know if I'm going to hit, I don't know if I'm going to talk about holes a lot. Holes are like when things cancel out. When we factor and things cancel out. Watch, I'll show you when we do the first one. Okay? So the first thing. So we have numerator, denominator. Example 1a. We have to find the vertical asymptote, if there is one. Normally what we would do is look at the bottom and say, hey, when is that going to be equal to 0? But before we do that, we have to see if it can be factored, right? The top is a binomial, the bottom is a binomial. Let's see if it can be factored. So the top is a binomial. Can that one be factored? Yes, right? It's a difference of squares. Okay. Can the bottom be factored? Yes, right? They both have, not difference of squares, right? But it's got a GCF of 2. Okay. Does anything cancel out? No. So let's picture something did cancel out. Let's say, don't change this in your notes, but let's say this was actually x minus 1. These guys would cancel out, right? That would give me a hole. It would give me a hole at positive 1 because it's x minus 1, and that 1 is the 0 for x minus 1. So that's when we have a hole. Again, I'm not going to be, are you going to have questions about holes on your tests or quizzes? No, I'm not really. We don't really cover that in this class, but we do cover asymptotes. So nothing cancels out, right? Okay, so since nothing cancels out, now let's go focus on the denominator. Don't worry about the top. I don't care about the top anymore since nothing canceled out. Now what I'm going to do is figure out where the pink guy equals 0. So I'm going to set the pink equal to 0. Okay. I'm going to solve it for x. Distributive property. 2x minus 4 equals 0. I'm going to add 4 to both sides. Divide by 2. X equals 2. So what that means is there's a vertical asymptote at x equals 2. So if I were to graph this guy on my calculator on Desmos, I would expect to see a vertical asymptote at x equals 2. Okay. All right. Let's look at example B. Same thing. Well, before we do anything, if we can factor, factor. So the top is a binomial, but it's kind of written weird. 1 minus x, right? We're not used to seeing that. We're used to seeing the x first. So let's move them around. So when I move it around, the signs follow, right? So what sign does 1 have? So I got to give it a plus 1, right? What sign does negative have? Or sorry, I just said it. What sign does x have? Negative, right? The bottom is just a trinomial. Okay, so let's factor now. The top, let's start with the top, the numerator. Is there a GCF for the top? Yeah, I don't like my first term being negative. I don't like it. It's just me. I just don't feel comfortable when it's negative. So I'll factor out a -1. I'll divide by -1. That means x becomes positive, 1 becomes negative. It's going to help you later down the road of this problem too. Now let's look at the numerator. The denominator, the bottom. It's a trinomial. Doesn't have a GCF. So next step, let's do the first term is 1. The last term is 3, or coefficient, I should say. So we get a positive 3, and middle term is -4. Middle coefficient is -4. So what are the two numbers that multiply to be 3 but add to be -4? -3, -1. And then 1x squared, positive 3, -3x, -1x. X times x makes x squared, -3 and -1. Factor. Anything cancel out? X minus 1s will, right? So again, I'm not concerned about it, but that means there's a hole at +1. There's a hole at +1. Not really my concern right now. I'm just looking for vertical asymptotes. So let's rewrite it after it's been factored. I have -1 on top, x minus 3 on the bottom now. So now that it's factored, now I'm going to go down here and look. You could probably do this one in your head. Where is x? What value of x could I plug in that would make 0? 3, right? If you didn't know, just set it equal to 0. So we have a vertical asymptote at x equals 3. And a hole at x equals 1, but they didn't ask that. Okay. All right, let's look at letter. Try letter C. Try letter C. Do letter C on your own. Okay, so what's weird about C? So what? Yeah, keep going. What's weird about it though? What's weird in terms of what I'm trying to do? Find the vertical asymptote. What is that going to do? You're right. X plus 1 squared is going to do something. First of all, does anything cancel? No, I don't. I can rewrite it like this, but it's not going to help anything. Nothing cancels. Set the bottom equal to 0. All right. So I have to undo the left side. How do I undo, or what's the opposite of squared? Square root. So I got to take the square root of both sides. Square root of 0 is just 0. And then subtract 1 from both sides. So if I plug in -1 to the bottom, would I get 0 on the bottom? If I plug in -1 to the pink stuff, would it give me 0 on the bottom? Yeah. Vertical asymptote at x equals -1. Okay. So again, at those spots, -1, x equals -1, x equals 3, x equals 2. Now we're going to have to find the limits at those spots. So for this guy, these problems should look very similar, right? If I take away the limit part, isn't that just 1a? So we know where the vertical asymptote is, right? We know where the vertical asymptote. So I'm going to draw a little picture. I don't know what the rest of the graph looks like, but I'm going to draw a little picture just to help me out. So over here, I found that the vertical asymptote was at 2. So I don't know what's happening to the right of 2. I don't know what's happening to the left of 2. But I know at 2, there's a line you can't cross. So if it asks me what the limit is at 2, what are my only 2 choices? Positive infinity, negative infinity, right? Well, it's asking me just from one side, right? Let's say this was, it was just like that. What would the answer be? Yeah, there couldn't be one. Does not exist, right? So the only question they could ask me is from one side or the other. So the negative side means the left side. So we're coming in like this. We can't cross. I can either go up or I can go down. So we have to figure out which option is it, option A or option B. Okay, so when I did it earlier, when I did this problem earlier, I factored it, right? X plus 1, x minus 1, 2x minus 2. Okay, so what I'm going to have to do is plug in numbers to this guy here. Or this guy here. They're both the same. and figure out what type of numbers am I getting out. I'm either going to be getting out very, very big numbers up here because it's going up, or I'm going to get very, very small numbers because it's going down. So I'm going to try to figure out what it's doing. So the first thing I'm going to do, I'm going to try to plug in 1. What's happening at 1? All right, so what's happening at 1? So let me plug in 1. Let's see. So if I plug in 1, I get 2 times 0 over negative 2. Which is 0 over negative 2. What is 0 over negative 2? What is that really equal to? 0. So I know I have a dot here. So from that dot, I have 2 options. My graph is either going to go up or my graph is going to go down. I have to pick one more value in between 1 and 2. I don't care what the number is. I just want to know if it's a positive number or is it a negative number. Because if it's going to go up, it's going to stay going up. If it's going to go down, it's going to stay going down. It's not going to do one of these. It's not going to go like up and then it's not going to do that. It's either going to continue going up forever and ever and ever, or it's going to continue going down forever and ever and ever. So what I'm going to do now is I'm going to plug in a number between 1 and 2. 1.5. Do the same thing I just did, except I'm going to plug in 1.5. I don't really care if what the actual number is. I just want to know if it's positive or negative, right? It's not hard math. It's a little decimal math, but it's not hard. So the first parentheses are going to give me a positive number. The second parentheses are going to give me a positive number, right? So what's a positive times a positive? Positive. So I get a positive on top. On bottom, is it going to give me a positive or negative on bottom? Negative, right? That's going to be a negative times 2, which is negative 2. What is a positive divided by a negative? Always equal a negative number. So I know that it will be a negative number. And if you want to do the math, you can. It's going to be 2.5 plus 1.5, or sorry, 0.5, 3 over negative 2. That's what the actual answer will be. Right? So what that shows me is, hey, from that dot, this guy is going downhill. And it's going to keep going downhill. You could plug in 1.9, 1.9, 1.9, 1.99, 1.99, 1.999, and it would still be going down negative, negative, negative. That's what that tells me. So now it tells me that the limit as x approaches 2 from the left for this guy here is negative infinity. Negative infinity. Okay. Okay, let's try letter B. Let's try letter B now. We factored it already, right? We factored it already. If they ask you what's the limit, always factor first. We did it because they told us earlier that we need to do it. So let me rewrite this problem. It's the limit as x approaches 3 from the right side. What did I get? Negative 1 over x minus 3. I know that there's a vertical asymptote at x equals 3. We already know that. So they want to know what the limit is as I'm approaching it from the right. So let me draw a little picture. Sometimes it helps to draw a little picture because visually it's easier to see. Some people can picture it in their head. Sometimes I can, sometimes I can't, but it always helps to have a picture. Okay. So they want to know from the right side now, from the right side, what's going on? Are we going up or are we going down? Well, from the right side. Well, let's try 4. Let's see what's happening at 4. So let me plug in 4. It's at -1. Now, that doesn't necessarily mean that it's negative infinity. It could be coming up. It could be on its way up. What'll give me a better idea is if I pick another value that's in between 3 and 4, 3.5. Again, I don't care if it's what number it is. I just want to know if it's positive or negative. That's all I care about. Because if it's positive, I know it's going up. If it's negative, I know it's going down. Actually, wait. Since this one's negative, I need to know. So I need to know. The other one was 0, so I didn't need to know. This one, I need to know if it's a bigger negative or if it's going, which way is it going? This one, luckily, the math isn't that hard on this one. -1 over 0.5. What is -1 divided by 0.5? So in other words, -1 divided by 1/2. -1 times the reciprocal, so it'd be -2. So at 3.5, it's a bigger negative. That means I'm going in this direction. So what is the limit as x approaches 3 from the right? -infinity. Okay. I want you to try letter C. Try letter C. Try letter C on your own, and then I'll give you one more to try on your own. And then we'll be done. Okay, so for letter C, we knew there was an asymptote at -1. We're only caring for the left because of the left side. So at -2, I got +1 as an answer. And then as I got closer, so I put -1.5. When I did -1.5, I got 4 as an answer. So it's going up. Positive infinity. What? Letter D, we haven't done yet. Letter D, we have not done yet. So we didn't do it on the previous page. So we still have to factor it. So does letter D factor? No, it doesn't, right? The top is just x times x. The bottom is close to difference of squares, but it's not difference of squares. So it just stays x squared plus 4. So the bottom, so the whole thing does not factor at all. It stays not factorable. Okay. Is there any vertical asymptotes? Would this guy have vertical asymptotes? How do we know? What do we have to do to the bottom? So let's do that. Since we didn't do that in the first page, let's do it right now. Okay, subtract 4 from both sides. Take the square root, and what happens when we do this? What's the square root of negative 4? There is none, right? There is no real number. It's imaginary. It's imaginary. And I told you from the very beginning, imaginary numbers we don't deal with. So for this problem, there is no vertical asymptote. There is no vertical asymptote. There is no number that I can plug in for x on the bottom anywhere. That would give me 0 on the bottom. There is no number. It doesn't exist. It would have to be a imaginary number, and we don't deal with imaginary numbers in this class. That's the one thing we do. We don't do that Math 3 does. Math 3, you deal with a lot of imaginary stuff. Here, we don't deal with that. Okay. So if it doesn't have a vertical asymptote, then what do I do? Remember these guys I couldn't plug in -1 to the C. I couldn't plug in 3 to B. I couldn't plug in 2 to A. Why not? Because I would get 0 on the bottom, right? Well, is that a concern with letter D? No. So just plug it in, right? That's the best way to do it. If you can do it when you're doing limit problems, if you can plug in chug, plug in a number, get a number out, that's what you do every time. So I get 4 over 4 plus 4, which is 4 over 8, which is 1/2. If something doesn't have any vertical asymptotes, plug and chug. Plug it in. Okay. One more problem. Since we got about 15 or so minutes, I want to give you one more problem that we have not discussed.
Hey, can you go back to C real quick?
See? Sure.
I didn't catch everything.
Yeah. Let's see. I want to do that. Okay, so we didn't put a trig one in here, so I'm going to put a trig one in here real quick. So the limit as x approaches pi over 2 from the positive side for -2 cosine x. Don't worry about factoring because you can't factor this guy. Anything with, very rarely can you factor anything with cosine, with trig. I'll give you a hint. Use your tables. Use the tables that I gave you last week. Those will help. So can't factor it, but does this guy have a vertical asymptote? When I say, does it have a vertical asymptote, what I'm saying is there a value I can plug in for x that would give me 0 on the bottom? Which value? Cosine of what gives me 0? Pi over 2, right? Use your values, cosine, right, or pi over 2. So vertical asymptote, so we do have a vertical asymptote. At x equals pi over 2. Okay, so okay. So I care from the right side, right? Well, what comes after pi over 2 from the right side? 2 pi over 3. Okay. So I want to know where it's going. Where is it going? What comes over here on the other side? 3 pi over 4. Okay. So I'm going to plug in these values over here and see what I get. I'm going to plug in these values over here and see what I get. Luckily, I already know the answers because I have them on my chart. So the first thing I'm going to plug in is 3 pi over 4. So I'm going to say negative 2 over cosine 3 pi over 4. So I get negative 2. Go to your chart. What is cosine of 3 pi over 4? Negative what? Negative root 2 over 2. So it's negative 2 times 2 over negative root 2. So you get negative 4. No. Over root, negative root. So negative times a negative, positive, and then I multiply by rational. I get 4 root 2 over 2. Cancel those guys out. And I get 2 root 2. 2 root 2. Positive. It's going to be positive. So my last step is to see when I plug in this guy here, is it bigger than this guy here? If it is, it's going up. Is it smaller than this guy here? If it is, it's going down. Okay. So let's do that. Cosine of 2 pi over 3 is 1/2, negative 1/2. So I get negative 2 times negative 2 over 1, which is positive 4. Okay. So when I plugged in 3 pi over 4, I got a positive answer. I got 2 root 2, which is 2 times like 1.4. And then when I plugged in 2 pi over 3, I got positive 4 as an answer. So did I go up or down? I went up, right? I went up. So in that case, the limit is positive 3. Okay. I'll leave those up here for a second. I'm going to post these notes on Google Classroom just like I always do. So if you didn't catch something or want to look over something, I am going to. And then same thing with the video. Tomorrow, like I said, we're going to have the quiz. I don't imagine that the quiz is going to take you as long the second time because you know exactly what's going to be on it. Literally, the quiz will look like what your first quiz looked like. The only difference is some things will be scrambled around. It's going to have 6 problems. It's going to be the same type of problems. Okay. So tomorrow I'll have your assignment on this ready. So when you're done with the quiz, you can start on the assignment. Okay, and that's all we'll do. And then Wednesday we'll do the next lesson. Okay. All righty. And then I also told you I will give you this guy, just this part right here on your quiz. I'm not going to give you the bottom because that's the answers, but I'll give you the top. Okay.